So we are going to see what vectors are. So I'm going to show how we use them in Project Spark, and I'm not going to use Project Spark for the moment, but GeoGebra, which is a geometry software. The chat is disappearing each time I click on the other window. If someone knows how to get the chat without it disappearing. It's not a big problem. So I'll start by saying that vectors are really important, even in the real world. You can do a lot of things with it. And in Project Spark, there are not only vectors, and this is something which is really important. So you have vectors here, but you can also define points with the vector variable. I'm going to call that point. So in Project Spark, there is only one type, the vector type, for points and vectors. So I'm going to show you what's the difference. A point, it's just a position in the world, and it's a position according to the origin. So I'm going to show the origin. The origin is just 0, so it's a vector which has x, y, and z, which are all 0. And I'm going to show where it's in the world. So display, for example, I'm going to draw a sphere which center is point, so the vector 0, and with a radius of 2, for example. And you are going to see here it's my 0, 0 position. 0, 0, 0. There are 3 coordinates. So this is a point, an example of points, and if you want to define another position, you'll do, for example, I'm going to do point x. It's here in positioning, x, y, and z. Point x equal, and then you need a number. So for example, I'm going to do 2. And I can do the same with all of those coordinates. And you just need to remember that the y coordinate is up, x coordinate is east, and z coordinate is north. So, for example, this is another point which is defined by the origin 0, 0, 0, and I'm going to show it here on GeoGebra. So for example, the point 4, 3 is defined by the origin, and I'm going to choose a vector 0 from 4 in x direction. This is x, and 0 to 3 in y direction. So from C to D and from D to B, it's x equals 4 and y equals 3. So this is a point, Now I'm going to talk about the difference with a vector. But something that is important to note is that in maths, this vector and this one are the same vectors. This is really important. This is the base of everything. Hi and jk are the same vectors. So a vector is defined by only two things: its length, its magnitude, and its direction, so direction and length. But it's absolutely not defined by its position. So right now this vector, I can move it here, is the same vector. So I've talked about vectors, what they are. A vector is a point minus, you can define a vector by doing a point minus another point. So point A minus point B will give you the vector BA, its inverse. And I just wanted to talk about how to get a point by adding a point and a vector. So for example, if I have a point A and a vector BC, I can define a point here, which is going to be called D, which is going to be A plus vector BC. So C minus B. And this will give me the point B, D, which is just A translated by vector BC. So it's a little transformation in math which is really important, and you will need it a lot in Project Spark. I can do a demo. I just wanted to point out that the point and the points and vectors are coded the same way because they are both triplets of x, y, and z coordinates, but also because the point A is just 0.000, so the origin, plus the vector, the origin A. So that's why it's coded the same way. You can mix them in formulas, but you really need to pay attention when you're coding. Is my vector a point, so a position, or is it a vector, so no position but a direction and a length? So I'm going to do a little example, and I'm going to talk about trigonometry functions afterwards. So this is my goblin, and what if I wanted to move my player and the goblin stays at the same distance and same direction than when I started the game? So what you want to do here is just defining the vector when you start the game, like I did here, from A, from B. And in fact I'm just going to define the vector directly, so vector player goblin. I'm going to say position of the goblin minus my position. So this is the vector here, player to goblin, and now I want to define the position of my goblin to be at each frame my position plus the vector. So position of the goblin equals my position plus the vector. And as you can already tell, when you don't move, this will just be goblin position, because goblin position minus position plus position is goblin position. But when I'm moving, you can see that the goblin is staying there. So this is a good demonstration of the use of a vector. And I already talked about what you can do with the length of the vector. You can modify it. I'm going to read the chat before doing that. I'm still on. I'm going to put the chat here so I can read it. Because I'm finished with GeoGebra for now. So okay, so now I'm going to talk a little about trigonometry function, or maybe not. I don't need that for the moment. What I want to do now is I want my goblin to go from this position to this position, and oscillating between these two positions. And I'm going to show that, because it will demonstrate how to change the length of a vector. So I'm going to define a value which is going to be the length of the vector. And I'm going to change that multiplied by the length. As I said earlier, this will modify the length but not the direction, and I can change the length at every frame to change the position of my goblin. So for example, I will do duration timer, loop, and length. So timer seconds complete. It just said there the number of seconds that the timer will remain on and off. So if I have a duration which is 1 second, this will be between 0 and 1 second. So I can show what it's doing. You can see that it's changing the length of the vector. So now that I've talked about basic operations, I want to show what Project Spark has. Because it has some pretty interesting functions that you will need. So I'm going to talk about the most important one. Length, I've already talked about this. This will give the length of the vector, so as a number. Normal is just the direction of the vector. So instead of having the vector times, I'm going to show that in GeoGebra. So a vector is a direction and a length. Length will give me the length of f to g, and normal will give me the vector but with a length of 1. So for example here, if I want to have the vector normal fg, I'll just have a vector which is going to be fh here. If I modify the point j, for example here, the normal vector will be fh. So this is really useful if you want to have formulas with length, where you want to define a length. Because for example here, if my goblin was very far away, this length is huge. So if I wanted to have a vector of length 2, which is going to have the same direction as the vector from my position to the goblin's position, I can't just say vector goblin multiplied by 2, because this will not be of length 2, but 2 times length of the vector. But if I was to add normal here, this vector has the same direction as vector player goblin, but of length 2. It is of length 2. So that's what you would want. And another thing that I didn't say, if you multiply by a negative number, you will get the vector. For example, if you have a vector ig minus ij, sorry, so it minus ij is just ji. So this is ji. So multiplying by -1 just reverses the vector. So now, for example, if I want my goblin to oscillate between 2 meters from me and here, 2 meters maybe the other way, I could do that. Vector goblin normal. Okay, so position plus vector goblin normal times the length, which will be between -2 and 2. I'm going to delete that. So, for example, I can say 2 seconds, so it will be from 0 to 2. Then 4 seconds, and -2. And since timer seconds complete will be from 0 to 4, that will be from -2 to 2, and you will see that the goblin is going to oscillate between 2 meters here and 2 meters here. So that's it for the basic functions of vectors and the basic functions of project Spark for vectors. Now there is something way more complicated that I'm going to talk about. But first I would like to show what trigonometric functions are. I'm reading the chat. Yes, I'm teaching some vectors. So now I'm going to show the sine function, which you need to get one of the milestones, one of the challenges in Project Spark. I think it's here. So you need to use a trigonometric type. Sine is one of them, and as you can see, it's just a simple function which is going I need to change some little things. I'm not going to explain what I'm changing here, but this is not really important. Yeah. Okay, so now we're going to be able to talk about that function more easily. 360 and minus 360. So this is the sine function, and basically you just need to remember some values which are 0, 90 degrees, 180 degrees, 180 degrees, and 270 degrees, which basically are the most important angles. So, for example, it's lagging a bit. So this is 90 degrees, this is 180, this is 270, and we're going back to 0 degrees. And the sine function just demands an angle. So in Project Spark it's in degrees, and sine 0 degrees is 0, sine 90 degrees is 1, sine 180 is 0, and sine 270 is minus 1. So that's it for sine, but now cosine. I still need to do something. In fact, what I'm doing here is I'm just converting radians to degrees, because angles can have different units. So now this is the cosine function. As you can see, it's not just the sine functions reversed. It's actually just the same function as the sine, but with 90 degrees different. So cosine 0 is 1, cosine 90 is 0, cosine 270 is minus 1, cosine 180 is minus 1, and cosine 270 is 0. So these are the most important values, and for the other one you can just refer to your calculator. But why am I talking about these functions? Because I want to talk about another function for vectors. So I've talked about length, normal, but what is dot? Yes, so the dot is just a product, so you need two vectors. And this will give you a number. So the dot product gives a number, and I'm going to show why it's important, why this function is important. So if you take two vectors and you're doing the dot product, there are several cases. Your vectors can have the same direction, and then the dot product dot equals A and C equals A. As you can see, it's a number which is equal to, we don't care really. But what is important here is that this dot product is positive, because the two vectors have the same direction. But now, if the angles between the two, the angles, so it's that angle. No. Unfortunately, still lagging a bit. Okay, that works. So if the vector, the angle between the two vectors is 90 degrees, the dot product will be 0. I'm going to show that here. So vector AB, vector AC, the dot product is 0. Now if the vectors are of opposite direction, the number will be negative, and again 90 degrees is 0. So the dot product is really useful if you want to know if the vector, which is modified, changes direction. So for example, on my goblin example, I can tell if the goblin has changed from the right of the player to the left of the player by asking if the dot product of my vector goblin, player goblin, and east have changed. So greater than 0. I'm going to display, for example, is on right, else I'm going to display is on left. I'm going to make sure the goblin moves only on the x-axis, so east, west is on the right, and that doesn't work. So way to change the length of the line. Just so we can see better. I'm going to display the dot product to see what the problem is. So my brain is broken, so display dot code. Okay, so I think I know. It's just because I don't change the value of vector player goblin. I only change the vector goblin position minus my position. So I'm going to add a vector. So this is the vector from my player to the goblin browser. And now I want to do the dot product of vector and east to see if the goblin is on the left or on the right. So as you can see, this work is on the left, it's on the right. So this is one useful use of the dot product. And just so you can know what it does. Oh, hello, Plumbing King. So the formula is using the cosine, so that's why I did trigonometric functions earlier. It's just dot of a vector u and a vector v is equal to the length of u times the length of v. So that's why I said that the number isn't really important. It's the sign which is important. The sign is it's just given by this little factor cosine of your vector u and v. So this is an angle between the vector u and vector v. So in this the vector u is just AB, the vector v is just AC, and the angle UV is the angle alpha, which is here. So you can now understand why the dot product is equal to 0 in these positions. It's just because the cosine of UV is cosine 90 degrees, and I showed that cosine here it's 1, here at 90 degrees it's 0, so it's normal that it gives 0. And now when the vectors have two different directions, it just gives -1, and that's why the dot product is negative. So I hope you understand these functions and their usefulness. I haven't talked about the last function, well, projecting onto. I'm going to show what it does afterwards. And cross product, it's a bit more complicated because it is in 3D. A cross product gives not a number but a vector. So I'm going to use another vector. And I'm not going into details about this because cross product is more complicated than dot product. So I'm adding normal because east is not really just a vector. You need to put normal in these formulas. And it just gives the same thing. East normal is just east in the same thing. And I'm going to show what the vector 2 is. So I'm getting rid of everything else. And display in the vector east. And display east. Well, draw line is a better idea. From my position to my position plus east. As I said, a vector plus a point is a point. So this will give me my position translated by the vector east. I can show you what it does. There's still a bug. Should not disappear. So I saw that putting red will work. Okay, I don't really understand why it's disappearing. Someone knows? Well, I could do something else. Just recast heat because it has some debugging which displays the line. So I'm going to use that. Even if I'm not using the recast heat itself. Okay, this will work. So, and this doesn't work. Okay. I'm going to see if that's changing anything. I really don't know why it's not displaying. It worked in my other levels, so position to center. Multiplied by 2, so we can see it better. Ah, this works. So it must probably be position. I think that position is in fact my feet positions, so the position of my feet, and it may be that it's drawing the line in the ground, so I don't see it. So center sorted that. So now what I'm displaying is the east vector. I'm going to display the north. So copy paste, but with north. And I'm going to display that that vector 2. So you can see what it does. So vector east is the vector, the direction I'm going in, north there, and the vector 2 is in fact the upward direction here. And I can tell you that if two vectors are in the same plane, so for example here I'm in the 2D plane, and each vector I put here are in the same plane, I can't go out of the screen. But if I had to do the cross product of two of these vectors, the vector it would give me would go out on the screen. So that's basically what cross product does. It gives a vector which is in fact perpendicular to the two vectors you gave. So now that I've talked about all the functions, I'm going to show a little formula which is interesting because it's the snooker formula. So for example, if I wanted to shoot a projectile which bounces off an object, so I'm going to use a cube for that. Big cube. I can do shoot, for example. I'm going to do that. We'll shoot here. So shoot has a modifier which is called bounce and impact, and you can see when I shoot this bounces, but here I'm going to show the formula for that. If you don't want to shoot but create a projectile, you don't have bounce and impact, so I'm going to create a template. You can really put in the chat now, because I don't need GeoGebra anymore. So this so this is now a template. I can use it to create projectiles. And when I'm shooting it, I want this to move in direction, and here I need a direction, so I need a vector. I'm just going to use the forward vector, which is the direction the projectile is facing. Now you can see I press, no, you can't see it. Add position. Okay, so now that we are, I still need two things. So the forward vector is the direction it's facing, and right now it's facing in this direction. So I think it must be south. So, but I want it to face the direction I'm facing. So I'm going to use an object variable, projectile, equals create the projectile. So now I can use this object variable to change the forward vector. And I can ask it to be equal to my forward vector, the forward vector of my player. And second thing, I need to delete the basic code. Okay, now that should work. Still a little problem. I'm setting the forward direction of the projectile at each frame, so I need to do it only when I create the projectile, so that's better. But now you can see that it goes through the tube